Hello, welcome to SQL02pro.com. This is Hassan Mir. In this tutorial, I will introduce Oracle SQL to you. Okay, so topics we will cover today is what is SQL. We'll talk about database tables, and we're going to talk about a little bit of SQL history. So what is SQL? First of all, you need to know SQL stands for Structured Query Language. Okay. Now, I'm representing a database with this structure here, and within the database you can see we have a couple of objects. Okay, and I'm representing data objects. So let's say we have a data in the database. Now, database software manages data. Okay, and this is you, and you want to talk to the database. Okay, why do you want to talk to the database? Because you might want to retrieve some data, you might want to insert new data, you might want to modify data, or you might want to remove some data. Okay, so how would you talk to the database? The only language a relational database understands is SQL, Structured Query Language. Alright, so you're going to be writing SQL statements in order to do all these tasks. Now, I've changed the diagram a little bit because you just don't talk to database like that, right? You need some kind of software called query tool. Okay, because in this software you'll be writing all the SQL statements, and this software will be sending all the messages to the database, and database will be sending the result back to this query tool software, and that's how you know what data is residing in the database. Database is a software that runs in the back end. You can't just see the software, right? It doesn't have a graphic user interface. You need another software to talk to the database. Okay, now example of the query tools are Toad, iSQL Plus, SQL Navigator. There are tons of query tools available. Okay, now let's complicate diagram a little bit. Now, this is the query tool, and you're writing all the SQL statements query tool, and query tool is basically talking to the database. Okay, and showing you the result given by the database back to you. Now, what is this? There are other things that talk to the database as well. For example, applications, software, or website, etc., etc. Okay, now when you write a software or application for a specific purpose, there are tons of SQL statements coded within the software for a specific purpose. Okay, for example, when you go to a website, you buy something. The website is basically an application, an internet store or something like that. That internet store has lots of built-in logic. For example, when you buy a software, the internet store sends the message back to the database that, hey, remove one software from the inventory because it's sold, etc., etc. Right? So lots of SQL statements are built into into the applications. So it's not only you writing ad hoc SQL statements on the query tool, also built-in SQL statements are also sent to the database by the applications. Okay, so as far as the database is concerned, anybody can talk to the database through using SQL. A human by writing SQL statement, query tool, or application. Okay, Oracle simply, or any relational database, simply gonna give the result back to you. Okay, now let's talk about a table. What is a table? Consider a table as an Excel sheet. It has columns and it has multiple rows. Columns are representing, first of all, the table is representing an entity, the real entity in life. For example, if you want to store contact information about your friend, you will create a table contacts. Okay, so each row in a contact table will represent some instance of a contact, right? So this is your friend 1, this is your friend 2, etc., etc. Now each column represents some attribute of the entity. For example, first name, last name, phone. So you're gonna create columns for all those attributes that you're interested in, or your business logic is interested in. Okay, so you can have table called employees that will have information about your employees. Department table would have information about your departments, etc., etc. Alright, so usually, like, we include ID column in each table so that each record can be uniquely identified, right? We can have two people by the same first name, last name, and perhaps by the same phone number. So it's not a good identification. Combination of first name and last name is not a unique identification. So usually IDs are kept, so sequential increment, they're sequentially incremented. Okay, so the intersection of a row and column is a value. So this is column, this is row. Okay, so that's how the table looks like. And the data basically resides in a table, and you write SQL statements to retrieve data and put data back and modify data and to delete data. Okay, let's talk about a little bit of SQL history. So we used to have flat file systems long time ago, and still companies have flat file system because they perform much better and they're much faster. The problem with the flat file system was, like, let's say there's a flat file system, flat file system would have multiple files. Each file would be storing data. There was no specific format. Like file 1 has data about department, about employee. First line is about department, and then multiple like each line after that are representing employee within the department, and suddenly department 2 line would start. So there is no defined structure. And how you're going to retrieve data? In order to retrieve data, you need to have the proprietary logic in hand, because you need to know how the file is storing data. Is there like column wise data is stored, or is it like much in a loop wise fashion? Like this is like loop data, right? Department record, then all the employees within the department, then department 2 record. So like the logic is basically it will differ from each company to company. Okay, so if a programmer leaves, the next programmer comes in, the next programmer needs to know how this company work, how they store data. There's no proper standard. Okay, so this is the picture now. Like we have relational databases, we have like the data is stored in proper structures, and we have a standard to talk to the database. For example, like SQL statement can be used to retrieve any information from employee table. All you need to know is the ID of the employee or the name of the employee. You can say select a column, whatever column you're interested in, from employee table where the condition ID is equal to that or this, like a English language. That's how you write your SQL statement. They have a proper syntax, and here there is no structure. Like you have to write a complicated, perhaps C programs to retrieve data. So that was a big problem. Okay, so your take home should be the problem with the flat file system was there was no standard. Each company would have their own standard, and that was causing problem. Now in 1970, a scientist called Cod, E.F. Cod, he was an IBM scientist, realized this problem. Okay, and he tried to standardize things, and he created a data model and a language. Okay, data model is basically create how to store data in a standard fashion, and a language to talk to that, with the database. Okay, the language was called DSL Alpha. Okay, then IBM basically saw profitable opportunity, and they created System R project. Okay, to leverage on Cod's findings. System R team simplified the language a bit. Okay, and the language is now called DSL's called like the language that used to call DSL was now called Square. DSL Square was changed to SQL, and SQL then become SQL. Okay, so SQL is still now called SQL. SQL and SQL are like synonymous used terms. Okay, so now Oracle Corporation, suddenly they came into the picture in 1977. It's a pretty old company, older than Microsoft. The only reason this corporation was founded was to capitalize on Cod's findings. So IBM also started their project, and Oracle came in and they released the first relational database before IBM. Okay, now today Oracle database is the most popular relational database in the market. Okay, that's pretty much it. This is a quick introduction on SQL. For more tutorials, you can go to the website sql02pro.com. Here I would basically give you a demonstration on real SQL and tell you how to install your own database so that you can practice SQL, and in step-by-step manner I will make you a pro in SQL. Alright, goodbye everybody.